go over inverse variation with you now. Okay. So one of the biggest things that we talked about was direct variation. Inverse variation comes up even more. Okay. Um, Direct variation, as you should remember, is the relationship where as one value increases, the other increases, or conversely, as one decreases, the other decreases. Think of the idea as you eat more, your weight goes up. Okay, those are directly proportional usually. Right? It actually makes a proportion. Proportion, aka two things, two fractions that are equal. Right? An inverse variation is not a proportion. It's looked at as two products that are equal. Okay. Or sometimes you're going to see it as xy equals a constant. Okay. Direct variation was xy, x divided by y equals a constant. Okay. So this is the way we're going to look at it. Okay. Two products that are equal to something. Okay. An inverse variation problem uses two products that are equal to each other, like I said. Okay. Usually one side of it, the equals, is equal to a number, or you're going to have this wonderful constant, the constant of variation it's sometimes called. Okay, so it's the next line. In word problems, the cue that we're dealing with inverse variation is the phrase x vary and y vary inversely, or x varies inversely to y, or inversely proportional is another time used. Sometimes we have to find the constant of variation. That means what's the magic product they're always going to equal to? For example, the number of days it takes to complete a job varies indirectly as the number of workers assigned to the job. AKA, as you have more workers, it takes less days. If it takes 2 days for 10 workers to complete the job, how long will it take 5 workers? Well, 2 workers, okay, the constant variation is the product of the number of workers and the number of days it takes. So 2 times 10, which is 20. So it's kind of like this wonderful unit that it's always going to equal. If you take those two things, it's always going to give you 20. So if you have 5 workers, well, you have 5 workers. I don't know how many days it's going to take, but it's going to equal this wonderful constant, which is 20. In this case, it takes 4. Okay, and all it is usually it's the product of 2 equals the constant, and then you solve again that product. Okay. One of the most fundamental concepts about inverse variation is that if one of the quantities is increased by a factor, the other quantity is reduced by the reciprocal. Okay. Of that factor. So if x is doubled, y has got to be halved. If something's tripled, it's got to be 1/3. So if it's quadrupled, it's going to be reduced by a fourth. Okay. So like I said, if r varies inversely to s, if s is doubled, r is going to be multiplied by a half. Okay. The speed of a laundry truck varies inversely with the time it takes to reach its destination. If the truck takes 3 hours to reach its destination traveling at a constant speed of 50 miles per hour, how long will it reach the same location when it travels at a constant speed of 60 miles an hour? All right. So 3 hours times 50 is going to be 150. In other words, think about it. Does it make sense? They're going 150 miles. Okay. Well, that's where you're going. That distance is going to change. Okay. Well, if you go 60 miles per hour, I'm still going the 150 miles per hour. So if you divide by 60, we look at that. So 15 over 6, that's 2. See, don't need a calculator. 3, 0. How many times does 6 go in that? 0.5. And we have our wonderful answer of, there we go. As long as it's right. Okay. So, and does it make sense that it takes less time if you go faster? Okay. A pulley has a diameter of 8 inches, and one has a diameter of 12 inches. If the 8 inch is running at 1,548 RPMs, revolutions per minute, and it varies inversely to their diameters, how many revolutions, okay? So xy equals xy, or it's going to be our constant, so you multiply 8 times 1,548. Now, I highly recommend that you do have a calculator on hand, and I do have one. And if you multiply those two together, you're going to get 8 times 1,548. you get 1, 2, 3, 8, 4. Okay. In other words, you're going to get 1, 2, 3, 8, 4. Okay. Well, if I'm going by 12, so that's 12 and then a y. So you're going to divide it by 12, and you get 1,000. It's going to make 1,032 revolutions per minute. Right. And for a rectangular garden with a fixed area, the length of the garden varies inversely with the width. Which equation represents the situation for the area of 36 square units? Well, if you take a look, if you take the 2, first of all, does it even do add to get them? To get 36? No. Same with the subtraction. It could be either 4 or 2. Well, if I look, 36 is fixed. So this is like xy equals 36. This over here is x over y over x equals 36. Okay. If you look, this is a direct variation. This is inverse or indirect. Okay. And think about it. If you have a fixed strength of 36 units, if the height or if the width goes up, the length better go down to keep that. So 2 is our final answer. Okay. Kamisha is playing in a band in a graduation party. The amount of members, the amount each member earns, D, varies inversely to the number of members who played. Okay. If we take a look at this, it means the idea is if you're paying, if you have more people, each person's going to pay less, right? Well, to do this, it's not a direct variation. It's not a parabola. An ellipse is a circle. We're going to deal with what we call a hyperbola. Okay? And a hyperbola is the things we're going to have to take a look at in graph today. Okay? The graph of a hyperbola is different. Okay, first of all, there are no x squared terms in it. Okay? Remember, as x increases, y decreases. And as x decreases, y increases. The hyperbolas that we're going to make with the indirect variation or inverse variations are going to have pretty cool. Okay, think of them as x, y equals a constant. You're multiplying two things to equal some number. There are two branches to a hyperbola. So for an indirect variation problem with a positive constant, give me with a positive. So you need two things you multiply to give me a positive number. Well, all the numbers in the first quadrant are positive times positive. In the third quadrant, it's a negative times a negative, right? That gives you a positive. Well, if it's a negative c, it's going to be quadrants 2 and 4 because I think quadrants 2 is negative x, positive y. Quadrant 4 is positive x, negative y. Okay. The vertex, or the turning point of a hyperbola, is equal to the square root of the constant of variation, okay? Both the positive and negative values of it, right? And the most important thing we have to realize is this term asymptote. An asymptote is a line which the graph gets infinitely close to and never touches. Okay, we're going to see graphs, and they're going to butt right up against that line, but they're going to look like they're on top of it. But they're never going to touch. It's going to get closer and closer and closer and closer and closer. We're never going to get there. Okay, so let's graph some of these. So this right here looks like a constant of variation is positive. So it's like xy equals a positive number like 8. Okay. Well, this one is going to be xy equals negative 8. Now, notice how there's different graphs. One graph is the way to do it. Okay. The asymptote on this line is right here. Notice how that gets infinitely close to that line. There's actually a vertical one, too. It gets infinitely close to that line, but it never touches it. Okay. And that's going to be true. They're all going to look like this. Okay. So we need to be able to graph some. So let's graph xy equals 4. So if I graph it, I'm going to put my axis up. Okay. If you wanted to, it's easy to just make a t-chart just to show it. X, Y. Give me things to multiply. Give me 4. 1 and 4. 2 and 2. How about 1/2 and 8? Okay. And 8 and 1/2. Okay. Can we flip all these points? And do 4 and 1? Does that work? Yeah, it does. Let's graph this. So 1 over 4 up, 2 over 2 up, 4 over 1 up, 8 over 1/2 up, 1, 2, 3, 4, 5, 6, 7, 8, and 1/2, 8. 1, 2, 3, 4, 5, 6, 7, 8 is there. And you can see it there. Okay. Of course, you're going to draw better. But that's only one half of the branches. There's another one. Well, all you got to do is make them all negative, and you get the same stuff. So -2, -2, -1, -4 is right there. -4, -1, and then there's the other ones here. Okay, you can see it. Okay. See, the asymptotes are the axis. This right here is our wonderful turning point. See, it's kind of like right in the middle. And we have, notice how it's in the first and third quadrants, because it's positive constant variation, right? By the way, if you were to graph this on the calculator, you would use 4/x and hold to it. Also, notice how it's undefined at 0. Notice how there's a problem there. We can't think about two numbers multiplied together will never give you 4 if one of them's 0. Okay, that's a bad one. Now over here we have the same similar problem. Okay, and I'll draw my axis. But it's a little easier when the number's a little bigger because it gives you a bigger choice. We need negative numbers. So what gives you 16? How about 8 and 2? Well, we got to make one of them negative. All right, we can do -2 and 8. We could do 4 and 4. One of them's going to be negative. All right. And then if we try 1 and 16 and 61, we're going to run out of space. Alright, so -4, 2, 3, 4 is there. -8, 1, 2, 3, 4, 5, 6, 7, 8, 2. And then -2, 1, 2, 3, 4, 5, 6. See how it's kind of stretched out? If we did -1 and 16, it'd be like super high up here. So you can see it kind of widens it out. But it's still going to make the same shape. Now, of course, we can then just switch these to -2, 8, -8, 2, 4. Okay, we can make these positive. You get the gist. You can just switch these over, hopefully. And if we do 4/4 down, then so on and so forth, we're going to get the other branch. The bigger the number, the wider it's going to spread out from the axis. So those are your inverse variation. Think of it as one goes up, the other goes down. It's not a proportion. Don't make it a proportion, okay? You guys, good luck, and I'll take it easy.